Hi, this is section 1.1, and we're going to start talking about the different number sets that we have in mathematics. We have two main number sets. We have the real numbers and we have the imaginary numbers. Now, the easiest way to think of this is if we have a number line and we'll put 0 in the middle, and then we have 1, 2, 3, and then we have some negative numbers. And squeeze a -3 back here. If it is a real number, we will be able to plot a point on this number line someplace. So for example, we see this 1.6 repeating right here. Well, we can find a 1.6 repeating maybe someplace in this vicinity, 1.6 repeating. So we can put that spot on the number line. Even if we look, well, we can even nice in here. In the natural number, you see this 3. We can put the 3 right here, also good. We also have these irrational numbers. Okay, well, if I type in my calculator square root of 3, I'm seeing 1.7 and then some decimals. So 1.7, well, that would come very close to after this one would be someplace in there. All of those numbers would be considered real numbers because they have a place on the number line. An imaginary number would not have a place on the number line. That'd be someplace like way up here. So that's what real is versus imaginary. So every number in here has a corresponding spot on the number line. We can identify imaginary numbers because they have a negative underneath the radical. So if the negative's underneath, it's imaginary. Okay. Within the real numbers, all real numbers, so every number on this number line can be split into two groups, the rational or the irrational. Irrational numbers have a decimal form that never ends, nor does it repeat. So irrational numbers, we can say the decimal does not, we can say terminate, that means it doesn't end. It does not terminate, nor does it repeat. And we're familiar with pi. We know that that decimal goes on forever. So do the radicals that have these numbers inside that are, we say, are not perfect. Meaning, can we multiply any number times itself to give us 3? No, we can't do 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Nothing gives us 3. Same thing with 5. We can't take any number and multiply it by itself to give us 5. Therefore, these are all irrational. Rational numbers, the first 5 letters spell ratio. These decimals either repeat or they terminate. 4.72, that's a terminating decimal. -3/8, well, anytime we see a fraction, that's a ratio, so automatically we know that's a rational number as long as none of the irrationals are within that fraction. 1.6 repeating, well, that's a repeating decimal, so it's rational. And again, we see a fraction. Fractions are rational, so we're good there. Now, within the rational set, we have these other number sets. We also have the integers, the whole, and the natural. We're actually going to start with the natural numbers first. Another name for the natural numbers are the counting numbers. We can think of these as if you had to count, let's say, how many desks are in a classroom. You start at the number 1 and you go up from there. We do not include 0 if we're counting something. We start with 1. There are no fractions, no decimals, 1, 2, 3, 4, 5, and so forth. Now, if we take this set of natural numbers and add 0, that's the set of whole numbers. So the whole numbers are all of the natural numbers and 0. And now the next set, these two lie within the set of the integers. The set of the integers are all of the whole numbers and their opposites, which means we're bringing in the negatives. These 3 number sets, though, notice these 3 here, they do not have fractions nor decimals in them. Fractions and decimals are in the set of the rational numbers. Now, sometimes numbers might simplify and fall into a number set. For example, if we see 10 over 2, That looks like a fraction. You might say rational and it can't be anything else. However, when we simplify this, this simplifies to a 5. 5 would be a natural number. So if something simplifies, you want to do that first. Very similarly, if we have a square root, but this time I'm going to put 16 in here. Can we multiply any number by itself to give us 16? Yes, 4. 4 times 4 is 16. So the square root of 16 simplifies to a 4. So that would all be a natural number as well. So make sure you simplify. Okay, so what I would like you to do after that description of all those number sets, I want you to take a few minutes, you'll pause the video and match the definitions with the appropriate term. When you're finished, unpause the video. Okay, take a moment, pause the video if you need to, check your answers, make any corrections. If you know that you are going to have a hard time getting these definitions straight, I would highly recommend to make flashcards. These are a lot easier if you know the definitions of each of the different numbers. When you're ready, continue to the next page. Okay, the next thing we are talking about is absolute value. What absolute value is, it's the distance a number is from 0. And we note absolute value with 2 vertical bars. That would say the absolute value of A. How far away from 0 is that number? Let's look at an example. If I give you the fraction negative 3/4. So we have, what is the absolute value of a negative 3/4? Meaning, how far away from 0 is a negative 3/4? Right, that would be a positive 3/4. Good. Looking at another one. What if we have the absolute value of a negative 4.2, but we have another negative out front of this? Well, if we only look at this part first, what is the absolute value of a negative 4.2? Right, that's a positive 4.2. But what's the opposite of a positive 4.2? Right, that would be a negative 4.2. We could also view this negative, or we can say what's the opposite of the absolute value of negative 4.2, as a negative 1. So a negative 1 times the absolute value of negative 4.2. That's another way to look at it. Okay, moving on. The next thing we are talking about are reciprocals. The reciprocal of a number is formed by simply reversing the roles of the numerator and denominator. So if we have the number 6, now if it's not in a fraction, we can create a fraction. What number would be the denominator if you have a numerator of 6? Right, it would just be a 1. So to reverse those roles, the reciprocal of 6 over 1 would be 1 over 6. Good. Let's look at another one. What if we have a negative 3/5? What would the reciprocal of a negative 3/5 be? Right, a negative 5/3. And lastly, we'll give you one to try on your own. If you have 8 over the square root of 2, what would the reciprocal of this be? Correct, square root of 2 over 8. All right, the next thing, ordering numbers. What we're going to do now is take a set of numbers and put them in order, in this case, starting with the smallest. So list the following numbers in numerical order, starting with the smallest. It says you may wish to convert all values to decimal form for easier comparisons. What that means is when we look at 4 nines, do you know right off the top of your head what is the decimal equivalent to that? No, you might have to type it in your calculator, 4 divided by 9, to check to see what that is equal to. Same thing with the opposite of the square root of 11. If you need to, type in your calculator what the square root of 11 is, and you'll see it's a roughly 3.3, and then you have to make it negative. So what I would recommend for you to do first is take all these numbers and convert them to decimal form or simplify them, and then we can order them easily. When you're done, unpause and check with mine. Okay, here we have the decimal form of all of these values. When you get to the pi, what you need to do on your calculator is press the second and then the exponent button, which is above the division symbol. So second, and then that pi button on your calculator. If you didn't know either, the square root symbol, it's second, and then the button caddy corner from the 7. It has a little x squared, but a little teeny tiny above it is a square root. So you have to press the second button and then those. So now from here, once we have all their decimal approximations, we can order the numbers. So the smallest value we have here, right, it's going to be this negative 3.3, which is going to be the opposite of the square root of 11. The next one, we have another negative here, negative 1.57, which would be a negative pi over 2. Always make sure you use the original values and not the approximations. So this one, we're going to mark them off. I'm not scribbling these out completely in case I still need to see them. Let's see, that's all my negatives here. So let's go into the positive values. We have 0.4 repeating, which was given by the 4 9ths. And then we have a 1.7. And then we have 19/4. And then last but not least, we have the absolute value of negative 6. So that would be our number set from the smallest to the largest. Okay, last idea here, signs of inequality. We just are going to review what these symbols mean. We have this sign here, that means, right, this is less than, which means the symbol here is greater than. If we put the little line under it, what does that mean? Right, it could be equal to as well. So this would be is greater than or equal to. Same thing applies for this symbol. That could be is less than or equal to. And last one, example 5, place the correct sign of inequality between these two values. So we need to figure out, is this value less than or greater than this value? First, though, we have to simplify this. So looking at this one on the left-hand side, we see that we have the opposite of the absolute value of negative 6. We have to simplify all of this before we can add the 10. Well, just like we looked at previously, we have to look at the absolute value of negative 6, which is a positive 6. But then we have to bring down this negative and then still add the 10, which leaves us with negative 6 plus 10, which is a 4. On the right-hand side, what would this simplify to? Right, this would give us a 16 because the absolute value of negative 6 is positive 6 plus the absolute value of negative 10 is positive 10. 4 is less than 16, so therefore, this would be the correct sign of inequality. Okay, that is all we have for section 1.1. Good luck with the homework, and please let me know if you have any questions.